All right, so welcome back everyone watching us online. So we get our next session up here with Ori, co-authored by Jacob Moody, actually, who's currently not here on premise. So Ori is doing the presentation, and it's on security and especially what we are securing. And he still needs a few seconds.
Yep, I'll be here in about. Okay, so I'm going to be talking a little bit about security and what actually, what is the point of what we're doing? So this talk is going to be less presenting things, the cool shit that we've built, and more just grumbling, whining, and trying to get people to think a little bit about what should we build. So why am I talking about this? Well, am I here? Am I focused? Am I going to the next slide? Why is my cursor stuck?
It's moving.
No, I mean, yes, but it's not a cursor. My draw term just got.
Do you want me to control your laptop?
Oh, I got it. There we go. Okay, I'm good. It turns out I'm dumb. Okay, so maximize. Okay, so yeah, so basically, why are we talking about this? Well, this started a few years ago when we got a CVE from RCHTTPD. Specifically, what would happen is that we had a path traversal attack where you could put %2f into the URL and :/%2f %2f, and we were doing the unescaping of that one stage too late, and 4chan discovered this. And as you can imagine, they had a bunch of fun on our systems. Nothing too big came out of this. I think that the worst thing that we exposed was probably the list of subscribers to the mailing list and a couple of files that SL had not been planning on making public. But we still kind of went, well, okay, we've got this bug. We need to secure things, but also we have namespaces. How the hell did we fuck this up? Why was the web server able to get to the mailing list? So that's kind of the start of this. We started to build a few things that came out of this. One was private serve. So this is from, and both of these were mentioned in or discussed much more deeply in a talk by Jacob Moody at a previous IWP9, where private serve, basically you can take the /serve, go to /serve/new, and that'll create a new subserve, which you can then bind over the initial serve, and you now have your private namespace for your own serve operations. Great. Now you no longer have this global list of. Actually, taking a step back for everyone that's not familiar with serve. Serve is basically a way of passing file descriptors from one program to another. So if for example, you're running a file system, the file system may decide, hey, I want to become publicly mountable. Let me post my my file descriptor, my 9p file descriptor in /serve, and anyone can come in and mount that. As you can imagine, this is great for many things, but if you want to have your file system only mountable by some programs, it would be nice to have a serve that isn't global. So that's what we provided, a way of taking serve and saying, actually, I want a sub namespace. Let's only allow passing file descriptors within this namespace. chdev is another nice thing where I can talk a little bit about why there's this rfork flag called rforkm, rf no mount, which will turn off the ability to mount things and turn off the ability to walk to devices. So #s, for example, is your disk device. Your disk devices, you may not want a random web server to be able to access directly, raw, unmounted by the file system. It turns out that this is kind of bad if any user can read from it. There are other things that you may want to not actually provide, or just out of an abundance of caution, maybe someone probably can't do it, but why not lower your attack surface? So R4Chem is a really big hammer. It turns off all things, including /net and so on. So chdev is basically a way of saying, let's make things much more fine-grained. We can drop device by device, and now not everything is globally available. Okay, so we're in a better state. But then, well, why else am I talking about this? Because recently, I created a new patch for enterable namespaces. So what enterable namespaces does is, when you have a program and you decide to mount something, it will pretty much take the file descriptors and it'll hold on to them so that you can actually do the walks. At the moment, in current stock Plan 9, once you have a namespace, there's no way to actually access there's no way for a program outside of that namespace to enter it and to be able to do things. But it turns out it's really useful to be able to do things within a namespace. For example, if you want to plumb a file, it's really useful for the plumber to be able to say, actually, it's this file in this namespace. And you can be able to pass a reference to the namespace is useful. Or, for example, Rio, when you're tab completing, may want to actually look at the files that window can see rather than the ones that were available when you happen to start Rio, because every Rio window has its own namespace. So this is a really useful thing to have, but the question, of course, became, well, okay, but what does this mean for security? The conclusion that we tentatively have come to is it's fine. But the thing that became clear while we were discussing this is that we actually weren't sure what promises we thought we were making to the rest of the system. And it was very hard to discuss, because if we don't know what promises we're making, we don't know whether we've broken those promises. So we started kind of thinking about it and trying to figure out, what do we do? Well, so I'm going to start kind of tracing through a bit of that history and trying to come up with where we started, where we got to, and the big thing that I'm not going to get to, or that I'm going to only gloss over, is where we want to go. Because what I'm really hoping this talk does is open a discussion about it so that we can actually start being intentional about it and start debating it. Pretty much what I want to do is start arguments at the bar after. Okay, so, right. I did not want to switch that slide yet. In the beginning, what the Plan 9 network was a set of separate machines. You had an auth server, you had a CPU server, you had terminals. If someone was sitting at a terminal, they were the account that logs into a machine on Plan 9 is the host owner. If you're at a terminal, you're the one that logs in, you're the host owner. That means you can do anything to that machine. You can poke at raw memory, you can overwrite any process, you can debug anything. It's the same thing if you're the host owner of a machine. So this sounds an awful lot like root, and it kind of is, but kind of isn't. The big distinction is that if you're root on a Unix machine on a Unix network, you're root on every machine, assuming you've got shared logins. If you root on a Plan 9 system, then you're only root on that one machine. You're only the host owner for that one machine, but you can be restricted on a different machine. Okay, so physical access. If you have physical access on Plan 9, you have the machine. The other thing that used to be the assumption is the user is the unit of trust. If I'm the user, everything I do is within my domain. There's no point in protecting across users. I'll go into a bit more on this, but the short summary is that there are debug interfaces. If you have the debug interface, you control the process much like host owner for the entire machine. If you're the user, it's game over. You can control any process that you have started. And then the last thing is that we kind of assumed that processes were trustworthy. Like, you weren't going to be, like a process that I had started as the user was probably not going to be too much of an attack vector. Yeah, you could crash it, but it was the data you were feeding into it anyways. So what are you going to do? You're already the user. You can already execute arbitrary code. What's an arbitrary code execution going to do? So, that's the world that we started off with in the 90s. And some of this might not have been explicitly codified, but that's kind of the assumption that a lot of people were making. At least that's my read of it, because again, not explicitly codified. So what changed? Well, you may have heard this thing. It's kind of obscure. Never really made it never really made it, but it's called the internet. And some people have it these days. And what it does is that it lets you basically connect to machines that you don't own. And maybe you're just using a service on them. Maybe you're logging in. But I don't know everyone on the internet. There's like 50 people there. So this is something that, a world that we actually have to deal with, where not everyone using your machine is friendly. The software is buggy, crashy. There's a lot of times where we can find things like remote code execution, which in the previous world, we trusted the user. Things were relatively okay. If the user compromised their software, they compromised their own software. They didn't. And yeah, there were bugs, but it wasn't so big. The user's a fool. Like, I'm a fool. I make dumb mistakes on my computer. I run stuff that's not necessarily things that I trust. I take data off the internet and I put it into a browser. And as the complexity of the software became very, I'm not competent to administer a machine. The things are too big. There's too much to understand. The world is complex, and you have to be aware of all of the little nooks and crannies to run the system well. So this is kind of the world that we've ended up in. And what do we do? Well, I don't have an answer. I have a bunch of questions and a bunch of thoughts, and kind of a few approaches I think can make things easier for us to build reliable software. But I don't have the answers here. I want to start getting people to start helping me figure out where do we want to go to make our corner of the world better. So yeah, seriously, I'm not going to be presenting solutions here. So let's start thinking about this together. But let's start with, what exactly is our goal here? What do we actually think we care about the most? Well, what are we trying to protect? So the first thing, obviously, we've got our private data. Like, I don't necessarily want people to know about the journal where I write down my biggest fears and all the scams that I've been planning and all of the terrible things I do. So my private data is kind of an important thing to protect. Then there's stuff like our passwords, our credential information, the things that let other people know that I am me. This ties into the first one, but it's not the same. If I'm trying to authenticate to a system and you can authenticate as me, well, okay, you can withdraw things from my bank account. And that's not necessarily a system that we control, but it's a system you can compromise because we fail to control this system. And tied to it are reputations. Like, if someone can pretend to be me and start posting terrible things about how much, for example, just there's a lot of rude things you can say on the internet that will make people very angry. And if you can pretend to be me and do that, maybe I'm not so happy. There's a lot of things like, also our resources. So, for example, if someone breaks into one of our systems, they may not they may not care about my private data. Maybe I'm just a really boring person. I probably am. They may not care about logging into my bank accounts because I might be broke. But they may go, okay, well, at least I can mine some Bitcoin. I may be able to take your network information and start spamming people. You've got a bunch of resources on your network, and bad people may want to use them. So we want to prevent that. What else? I mean, this isn't a complete list, but it's a set of things that we probably want to start thinking about how we protect. So the other thing that's worth talking about is, for the purposes of the discussion, what do we need to secure? So we're going to start off by saying, we're in IWT, we're talking about securing a Plan 9 network. So a Plan 9 network with terminal, CPU server, auth server, and so on. Well, actually not so, and so on. That's it. it's running user software. So I'm a Plan 9 user. I run software on it, and I actually do things with my system. I will browse the internet with Mothra when I can, when the sites work, or NetSurf. I'll process all of my email on Plan 9. I'm still slightly annoyed when I have to use Gmail because it doesn't work very well on 9front, and certs. I never actually finished the last year's WIP. Anyways, there's things to do there. But basically, I do a lot of end-user software processing there. And while we're not big enough to be necessarily a massive target of attack, it's still, I would like things to be I'd like to reduce the blast radius for my own software and for my locally run software. But also, a Plan 9 network running services. So personally, I run shithub git9front.org, and that's running a web server, a Git server, a couple of other small services like 9p, and these are exposed to the internet. Then, yeah, as I said, Mothra Git. I'm not personally running UPass publicly, but the Plan 9 mailing lists are running on that, so Stanley Lieber is running this. And this is kind of a difficult, these are all kind of difficult to secure. I'll talk more about what the current situation is later in the talk, but that's kind of, think of a system that's, or a few systems, one where there's a user in front of them downloading data off the internet and actually accessing it, systems where we're running a bunch of web services. What do we want to do about it? And then, as they say, compromise is the art of the possible. Well, what's possible if you get compromised? If someone gets into your systems, what can they actually do to them? So let's start off with a few assumptions about who we're securing this, let's narrow down the assumptions a little bit. So we're going to assume that the user is malicious, like they want to break into your system. And I think this is probably where we want to do. And the software, some of it's broken. But for now, let's assume that the kernel is not just completely fucked. Like, yes, there are going to be bugs, and yes, there will be holes and issues. People will find remote code executions in the kernel, but that's not a part of the model. That's a part of the implementation, and I think, we just fix those. Right now, what I really want to think about is more what do we wish we could promise, implementation aside. So I think that if we consider, for example, Mothra, going back to that, well, if someone breaks Mothra, I'm logged in as a user. That means that they can get to my home directory and everything in it. They can get to my, and that's where I keep my data. I keep all my stuff in my home. There's a lot of stuff in my home directory, and some of it is actually stuff that I would be pretty sad if it got into the wild. There's the /temp, which on this is less bad than it would be on Unix, because on Unix, /temp is a completely global resource. If you can swap in a temp file when someone's not expecting it, you can compromise a completely different user. On Plan 9, /temp is really an alias for user username temp. So it's your home directory only. But that's still pretty bad if you have a malicious program that's trying to fuck with everything else you're trying to do. So they can still go in and, maybe Mothra changes the emails you're sending. Maybe Mothra goes in and fucks around with your Acme temp files or your SAM temp files. It may decide that it may be able to find a breakage in some other program and inject and just place things somewhere else in the right place for that. And then the last one, /proc doesn't sound like the big thing, but then you think about it and realize actually that's the debug interface. You can actually reach into any process that's running as my user and overwrite arbitrary memory in that. So once you've got a remote code execution in Mothra, you've got a remote code execution in every other program that I'm running. This is probably not the best thing. So what do we do about this? I don't know yet. Or if we consider git serve. So git serve, it's logged in as none. None is a much more restricted program. So, or sorry, not much more restricted program, much more restricted user. None cannot actually open files in /proc other than its own process, which means that if you break into git serve, you can debug git serve. This is much better, but none is weird in other ways, which I will get to in the future. It also, git serve also tries to restrict itself to only accessing the files under the Git repository it's serving. So the first thing it does after it reads the status line from the Git protocol. So the Git protocol basically says, I want to access this repository. And Git goes, oh, okay, you're accessing this repository. Well, I'm going to cd into that repository, or sorry, I'm going to cd into that repository and bind over /. So now the only thing available in your namespace are the contents of that repository. Break it and, well, now you can't get out of that repository. Your data is safe in theory, except unmount. So even rforkm does not prevent unmounting. This is kind of a big hole because, well, if someone gets a few, like a confused deputy and they can't quite get to unmount, we're safe. There's a higher threshold here than there might be if you were trying to, there's a higher threshold here than if we didn't drop these permissions, but you still but if you unmount the /, you can still get back to the state where you have all of the other files in your namespace. And this is touchy because there's rf no mount. Sorry, there's rf replace m replace on mount flag, where it will actually unmount the things under it first. This is the default, so it'll unmount everything under it first. But / is special because / is your root. So unmount interacts very poorly with bind and trying to actually drop namespaces. It's not good enough. And then we consider upas. Upas is kind of the big bad problem here, where it's logged in as none, so we've got something here. And everything in /mail/box it's owned by the user. So the user creates their own file in their own mailbox in upas. And every user that can get mail is in the upas group, which should have write-only permission to the mail directory, which means that at least if you break upas, in theory, you can't read everyone's mail. But it's also, upas is a mess of shell scripts where your SMTP program puts things into the pipe for, I believe, mail lib rewrite, which invokes a few shell scripts, which will put things back into rewrite and then eventually get things through to deliver, which may pipe things to a pipe to script, which will. There's a lot of stages in the delivery pipeline. It's kind of hairy to lock it down because there's basically arbitrary code everywhere. So the big question is, what can we do that will make things better without completely breaking everyone's scripts? Where maybe we're okay with taking some breakage. Maybe if you run, I don't know. Maybe once we get past the initial ingestion of the mail, we should not have internet access on the delivery pipeline, and we could be okay with that. Or maybe we do need it and we really want to reach out to some third-party spam server. I don't actually know what, or spam ranking server. I don't actually know what we're willing to do here, but there's a lot of routing, a lot of fiddly parts, and it'll take a lot of thought to come up with a good way of locking down upas even further than it is today, which is not very far. Okay. Let's talk a little bit about what other OSs do and how they approach things. OpenBSD, they're very well known for being security conscious. And they've got a couple of things here. The big hammer that they have is the combination of pledge, unveil, and privsep. So let's talk a little bit about what those are. Pledge. So pledge locks down the syscall sets. So there's a lot of syscalls that you can do on Unix. And maybe not all of them are ones that you want to do in every program. So for example, if you had a program like cat, well, cat doesn't do too much stuff, so it doesn't necessarily need network I/O. So you may pledge that it you may call pledge standard I/O. Pledge standard I/O says if I do anything like try to open a socket, kill the program. Something's gone wrong. This program needs to die. This call to pledge is actually not quite right. I realized this just now. Pledge actually has something for, and this is what my child programs are allowed to call, but that's not too important, just details. Okay, so that's what pledge does. It combines with a syscall called unveil that will basically cut down it'll narrow your namespace effectively. That's not the phrasing that the OpenBSD people use, but we're Plan 9 people. It narrows your namespace. So it takes, so for example, the first call to unveil will say that home ORI stuff should be accessible to the program calling this, but only for reads. And then home ORI downloads should be accessible to the program that we're running, but only for reads and writes. Like you can access everything in there. And then the last call to unveil, null null, that's actually probably the most important call. It says that no further modifications to your unveil sets are allowed. Because of course, if you're allowed to modify your unveil sets, you don't have unveil. Okay, so pledge on Plan 9, honestly, not very useful. We don't have very many syscalls, and the same syscalls get used for everything. Everything is read and write. Your network, read and write. Your stuff, your TLS connections, read and write. Your drawing, read and write. So pledge, not helpful. I think that our equivalent to pledge is probably chdev, which we already have. So the access to the devices that we drop, that's roughly, I'd say that fits roughly spiritually in the same place as pledge. The other thing that OpenBSD has is privsep. Privsep is basically, it's not a tool, it's a method of writing programs. So the way that privsep works is that you'll take for example, your SSH daemon, and there'll be a network listener that basically will listen on the network, but will have the ability to do nothing else. And when it gets a connection and it talks to the user, it will pass that off to the authentication server, or the authentication process, which will look at the user database, run the BSD auth, and make sure that the user is actually allowed to log in. And it will, and then it'll talk to the last process, which is the only process that's actually allowed to change users. And if you break any one of these processes independently, except for possibly the last one, they're not allowed to do that much of interest. And in a well-written and well-designed privsep system, the complicated, difficult, and likely buggy parts are isolated into a process that isn't allowed to do anything of interest, while the dangerous stuff is in a process that's not allowed to do anything difficult. The thing that makes all of this fit, and the last part that fits all of this together, is that OpenBSD observed that many programs have two phases to them. There's the initial startup part where they will acquire all the resources and they need some permissions for this. But then once they've acquired the resources, they're done. They don't need to open a new network connection because the connection's already open. They just read and write. They don't need to open the user database. They already authenticated the user. So you can wait until the initial setup phase is done and then drop privileges. So this is roughly how OpenBSD approaches locking down a lot of their stuff. Linux, I think we're all fairly familiar with it. They do a lot of namespaces. but they do namespace. They think of namespaces a little differently than us. They think, well, one kind of namespace is good. What if we had 50 of them? What if we had the network namespace, which is basically, what if you added a separate network stack that could have separate IP addresses and everything? The PID namespace, so every set of processes starts from PID 1 and goes as normal. The UTS namespace, which I believe, I don't remember exactly what it is. I think it's basically just your host name. Someone I'm sure can correct me, but I think that there's a host name plus a couple of other things, and I don't know why that needs to be its own thing. And there's a few others that I don't remember. But yeah, they've got a lot of this. Landlock, which is, honestly, it's similar in spirit to Unveil. There are details and differences in the details, but spiritually it's close enough that I'm not going to get into it and say the wrong things. And then the last one is seccomp BPF, which I've played around with quite a bit. It's kind of similar to Pledge, but it does a lot more. Specifically, Pledge, if you do the wrong thing, the OS kills you. You don't get a choice. seccomp BPF kind of started with that, but not quite. And now they have the ability to basically p-trace the process, and the p-tracing process will get a signal, and then it can decide whether it allows it. The other thing that it does differently is that there will be a specific list of syscalls that you're allowed to call, and Linux is always adding syscalls and changing the meaning of not changing the meaning of previous ones, adding new ones to do old things, and then eventually glibc will pick up those new syscalls, and there's nothing that actually maps, standard IO to this specific set of syscalls. You just have to know. And then glibc gets updated and your program starts dying because actually there's this IOU ring thing now that you haven't given permission to use, and seccomp BPF takes a decent idea, but the way that Linux is constructed, it ends up being kind of fragile. Still, it can be used in the same way. Okay, so the one I'm going to talk about is FreeBSD. And this is the one I'm least familiar with, so please yell at me if I say something that isn't quite right. But Capsicum is basically a capability-based system, and you switch into capability mode, and now you're not allowed to actually access what they call ambient authority, which, as far as I can tell, basically means the global file system namespace. You have to pass a capability in, and a capability is a file descriptor, and then anything that you access is a relative open to that. So you have to rewrite your program so that open turns into open@fd. And then there's a whole bunch of other changes you need to make around that. Cool. So this is a very, very quick tour of this. The last thing that I'll say is observing other systems. There are a few things that I've kind of noticed, themes that really work with making it easier to deal with. So first one, simple is better. If you can actually implement things without making a ton of changes to your system, you can understand it, and the changes are easily auditable. People use your security mechanisms. I'm not sure how many people have tried to do anything with SE Linux, but the usual advice for how do I make it work is exactly, turn it off. So if your advice for how do I use my security system is turn it off, maybe you've done things a little bit wrong. The program should do it. So this comes from the OpenBSD approach, where actually, if you're expecting the system administrator and the user to get this right, they're not. The program should be locking itself down as much as possible initially. And then the final thing, which actually comes from Docker, which is not the shining example of good software in general, but recursion is useful. Being able to take a system, containerize it, and then within the container, containerize a subsystem. It's actually a really nice way to do things. We also noticed this with /serve, where actually the point where we realized we got it right was when we could take a /serve program, and then or a program that used /serve and restricted it, and then it didn't actually even need to know it was running in a restricted /serve. It just restricts it even more. this also comes from the Windows systems should be transparent idea, where actually, if you're running in a Windows system, why can't I just run a Windows system? And if I'm running in a Windows system that's running in a Windows system, why not run another Windows system? Having to kind of think about the layering and how deep you are sucks. So let's not do that. Okay, so I'm going to quickly go through. Here are a few things that actually really worked really well in Plan 9. First one, factotum. The idea that we have a agent there that where you can put secrets in, but they don't come back out. This is actually really powerful. And yes, I'm aware of auth get password. The secrets can come out in some cases. That's a problem with the protocols. None of the native Plan 9 protocols or the ones that we like will have the secrets coming out of factotum. This is actually kind of similar to the idea of a TPM, which also works pretty well. Although I wish they were used for users rather than against them. We can get into that at the bar. But the factotum works brilliantly, and the whole separation of the auth server also works brilliantly. Fun fact, I run the Git Plan 9 server, and I can't actually add accounts to it on my own. The auth server is way off somewhere else. Stanley Lieber runs it, and without both of us adding an account, you can't do things on the Plan 9 system. The ability to distribute that responsibility is actually quite nice. And the other thing that works really well for us, namespaces. So we can talk a lot more about this, but namespaces, as far as I can tell, are basically equivalent to capabilities. You can start putting together a namespace where, this is in the paper. There's a lovely quote by Ursula K. Le Guin about how to have power over something, you just need to know its true name. Well, if you can name a resource, you have access to it. If you can't name it, it doesn't exist. You can't break into it, assuming that the kernel is working. So namespaces are amazing. We should do more of them. The parent process, when it's spawning a child, can look at what it wants the child to be able to do and start building up a namespace that will only contain the things that the child should be able to do. However, there are things that don't work so much in Plan 9. I just talked through all of that. None does not work very well. And then the other thing, namespaces. They work great, but they don't work. So I'll quickly go through the problems of none first. So none is one user. And it's one user that you run for everything that's not authenticated. And we've tried to put in a couple of hacks to work around this. Specifically, when you have none, and the other thing to know about none is that any user can become none. So none tries to mitigate some of the problems because, by saying, actually, none can't debug any processes, including the processes that none owns, which is useful. But it still shares all the file system permissions. It still shares all of the the file system permissions is really the big one. And everything is a file system, so everything permissions. So trying to build a system that secures itself here means that you either micromanage a ton of accounts, which is totally doable, or you're very careful about how none works. The other fun fallout from none, which we patched recently in Plan 9, or in 9front, it turns out that you can't actually run exportfs reliably under none because, exportfs will spawn a process in the background to do its I/O. And that process in the background will work until you actually want to cancel the I/O. And the way that exportfs does it by signaling that process. Except none's not allowed to signal processes. So what happens? Well, you leak the process. It dies, or it just sticks around forever. Oops. So this actually ended up being a problem on a bunch of our systems where after enough time, people would hit delete a bunch and try to clunk I/O. Flush I/O. And the tflush messages would leak processes, and eventually we would just run out. Oops. But really, that's not a security issue. That's more of a war story. The big problem is just it's one user. And then namespaces, again, the big problem with namespaces is narrowing. How do we say, actually, I don't want to give you access to the whole file server. I want to give you access to this slice of it. I don't want you to give you access to all of /net. I want to give you access to /net/TCP/123. I don't want to give you access to /git or /. I want to give you access to /user/git/repo name. I don't want you to give you access to /mail/box. I want you only to be able to write to /mail/box/ori/mail/ something that didn't already exist. Because actually, UPass right now, if you can guess the name of a previous message, you can overwrite it, assuming you've compromised the UPass process. Having only write permission on the directory is better than having open read-write permission on everything in there. But it does mean that if you can guess an email, you can overwrite it. And suddenly that email from your mom turned into a phishing email from your bank or something like that. Okay, so, we've got processes. So how do we fix it? Well, we've got some ideas. And the final thing is mounting. So we were talking about recursion. If you turn off mounting then suddenly my Git program can no longer take that directory and mount it over /. I've lost the capability to do things. Recursion doesn't work if you try to turn off mounting. Unmounting, again, So how do we make it so that maybe this thing just doesn't look like a mount point anymore? Is that something that we can do? I guess this is going back to this slide. So what can we do? Ephemeral, big problem with none is it's one user. Can we start making it so that every time you log in as none, you get an ephemeral user, something that's just there for that one session, but not none is effectively the nan of usernames. None not equal none. Yeah, I don't know exactly what we want to do here, but this is one of the thoughts that we've been playing around with. And then the question is that enough to do it just in the kernel, or does the file system need an ephemeral ID as well? And then how does that map to the permissions that are already on the disk? Namespace narrowing. So I was talking a little bit about that, but how do we make it so that maybe this mount point is not unmountable, but it doesn't look like a mount point, so that you don't have to turn off unmount permission entirely? Is a locked mount the appropriate way to do it, or do we want to do something else? What else can we do here? And then can we enumerate the problems? So this is actually where the presentation ends. I don't have a strong set of proposals, but these are some of the ideas that I kind of like, but also I kind of hate. So who has thoughts? Okay.
Okay, hi, Skip. So several things. First off, with the namespaces, do you think like combining it with the capability of exportfs-p, that kind of narrowing of the pattern versus it being mount point based or device based?
Right. So yeah, that's an interesting one, and it's not so the thing that we can do here is, yes, we can use exportfs. And exportfs will basically give you a clean namespace that doesn't really escape. You can't unmount bits of it. The problem, and it will work. The problem is now you've got an exportfs between that and everything you're doing. And then what if you recurse? Now you've got an exportfs that bounces to an exportfs, that bounces to an exportfs, that bounces to an exportfs, and it starts to kind of, how many layers of copying how many times do you want to copy? But yes, this is a workable option.
So on identities, right, on principles, we got the IDP with the identity provider, and that could be a local or external. There's got to be some sort of a mapping. I think the world is external, and whether you're Gmail or Facebook or GitHub, whatever, and which one of those to map to each other and to the local. I think there is, this is what I'm going to be showing with the IoT stuff. There is a place for resource providers to be their own entity, like CPU is, like file server is, when they're on standalone. In other words, without auth server, you really can't get on them, right? So the same principle should apply, but then again, it would be tied. The entitlement should be tied to a principle that then is identifiable by somebody, right? And who do you trust? So 9P resources on their own, like IoT devices, if I want to, connect to 50 different entities, want to connect to the environmental sensors in this room, they should be able to, so long as they have the rights to access them, right? So, those have to kind of almost be separated out in terms of identity provision. So it seems like some sort of a mapping is going to be required.
Yeah, and there's another thing that I didn't really talk about, which is, well, at the moment, authentication is just binary. It doesn't actually come with any capabilities or any, here's the specific things you want. And do we want to change that? I'm not so sure. I think namespaces and capabilities are isomorphic. It would be really interesting to be able to tie a login to a namespace, though.
Sorry, I had a couple notes written down. I thought it was interesting when you were talking about OpenBSD not wanting to trust admin or user, but then offering a model that requires the admin or user to run software that implements that trust when, I don't know, it seems like the flaw requires the admin or user to like run that software in the first place.
Well, okay. I think maybe I explained it poorly, but okay. I'll let you finish, sorry.
I think I get what was going for, but like I don't know. You can argue, right? Like I'm a user and I want to run like OpenOffice, and if OpenOffice doesn't use Pledge or whatever it is, then like I still have this issue.
Yeah. It's a thing it's a trade-off.
So
it would be good. And you can have a program that will pledge and unveil and then exec the next thing.
Fair.
But that doesn't buy you as much as just doing the right thing in the first place, because you don't have that. Because you really want to but you want to lock down. You can lock down a lot more tightly if you wait until the program's initialized. So the process. So to get things to work well, you need to modify the code.
The other thing that I wanted to discuss, like you said something about the relationship between namespaces and capabilities potentially being closely linked or potentially the same thing. I think one of the ways this falls over is you can know the names of things that you don't inherently have rights to, or alternatively, like you should be able to restrict the rights of named things. And like this falls over with a file system-based approach because in a file system-based API, you tend to expose a lot of notionally different capabilities via different file system nodes, where the acceptable risk of access to one of those nodes versus the other differs, and that's where you want to have a security boundary. And so Fuchsia does this somewhat with sort of stacked abstractions about what capability means, depending on what level you're running as, but they build on top of each other. And that's something I'd be happy to talk about.
Yeah, we should definitely talk
later.
more. Yes, we should definitely talk more about it. I think that there's some of this also will mean you need to do some co-design of. So my thought is that you also need to do some co-design of what you put into the namespace to get the full benefits, because you may have. The namespace, I think, still is isomorphic to a capability. But if you have a capability that happens to be, let's do everything, then you haven't really won. So you can't just put access to a file means you can do everything. Again, code design plus namespace narrowing. So on GEFS, I'm in the middle of actually putting together a patch that will move from the /serve/thing.cons, which is just a dumb pipe, to a CUDL file. The CUDL file it'll respect permissions, but also I'm splitting that from the just general info. So if you want to know how much disk space you're using, that's a separate file from the file that will allow you to shut down the file system. And you could put one of those into the namespace, but not the other.
All right. Yeah, we have one more question, and then I'm afraid we actually need to cut it here to stick a bit with the schedule at least.
Yeah, on your Motra example, so it should be possible to, for example, that it has access to your home directory. There's no reason for it, right?
Right.
So it should be easy to modify Motra. Actually, Motra just need 5 programs, right? It needs UHTML, TCS, and the GIF program. So you should be able at the beginning of Motra to just unmount, ch root and hide everything except /net, and it will work.
Kind of. But right now it's very hard to only allow access to the things in /bin, to certain files in /bin, for example. So
but already it will solve your /home problem.
Yes.
That's huge, right? That
exactly.
You say private data, Motra has no point in.
I agree.
And namespace are just good enough for this.
Yeah.
And of course /proc also to remove /proc.
Yes, there's a lot that we can already do. I would have to think about whether you can do it with something that's not solvable, or that can't be worked around with just unmounting. But yes, basically we have 80% of the. I think, actually, the last thought I'm going to say is that I think we have 80% of the building blocks, 90% of the building blocks. We just haven't clicked them together, and we're missing 3 or 4 small pieces.